is actually disappointing. Yun yung motibo.
Fuck you.
However, his recent story implies he pulled out from the gambling advertisement deal. I just hope it is sincere and real. I mean, if he did pull out from the advertising the gambling company, it just shows he actually listens and cares about his fans. Unlike those brain-rot content creators that prey on their fan and encourage them to gamble.
Why me?
Oh my God, mga kahombre ko. Actually, to tell you the truth, yan po yung pinakamasaklap na pwede mangyari sa isang influencer. Yung tipong hindi pala tanggap ng fanbase mo na ikaw ay gagawa ng ganitong klase ng situation, mga kahombre ko, di ba?
Ako naniniwala ako na tama yung ginagawa ko.
Pero again, para kasi sa mga influencer, no, this is big kasi super easy lang nito. Tas madali lang silang pepera dito. Kaya tinatanggap to. Kaya kami, tumatanggap kami ng ganito. Alam niyo yan. Pero sa isang banda, mga kahombre, napansin din naman natin, di ba, na maraming mga influencers ang nag-comply sa kagustuhan ng gobyerno. So, itinigil muna nila sa panahon na ito hanggat naghihintay pa, no, ng kung ano ba ang mangyayari at kaganapan nitong mga susunod na panahon, no. Kaya ganyan yung nangyari. And eventually, meron pa ring mga influencers ang patuloy pa rin. Makapal ba ang mga pagmumukha nila? Definitely.
Diyos mio naman.
Kasama na ba ako sa makakapal na mukha ng mga influencer na nagpo-promote ng ganito?
Ano bro? Anong sasagot mo?
Definitely yes.
Grabe.
Ayan talaga yung path na dinaanan ko.
Grabe talaga mga kamatis, mga kaibigan eh.
Hindi naman ako kay para itanggi yan. Sino ba naman tatanggi dyan? Wala. Hindi ako tatanggi dyan. And it's real. Pero syempre mga kahombre ko, may mga influencers din na hindi talaga kaya na tanggalin ito sa sistema nila. No? Kasi syempre, ito yung pinagkukuhanan nila. Yun, hintayin na lang natin kung anong gagawin at mangyayari in the past few weeks o days, kung ano ang sasabihin sa atin ng ating gobyerno. Kung pwede bang ituloy o hindi pwedeng ituloy. Anyhow, ganun talaga. Kasi napansin natin na nagkaroon ng ilang weeks, no, na tumahimik. Kaya marami kaming nagbalik, no, sa pag-promote. Pero dahil uminit ulit, di ibig sabihin hindi talaga siya pwede, hindi siya okay. So wala tayong choice kundi mag-stop and hintayin na lang kung ano magiging desisyon.
Sino bang linoko mo dyan, MG?
And eto na nga mga kahombre ko, no, up to this day, isa ito sa nakasira sa image ni Razi Binks. At ginagawa na lamang katatawanan ang kanyang mga uploaded contents na paukol sa insidente na ito. Magtataka kayo kasi talagang lahat mga kahombre ko, as in totally lahat po sa comment section, puro ganyan po ang comment. Grabe yung nangyari sa kanya na to. Nabuo din dito ang katagang Just My Location, Sir. Kung saan nag-originate naman ito sa isang namayapang Filipino soldier na nagbitaw ng salitang Just Bomb My Location, Sir. Hindi natin alam bakit nabuo yung katagang yan ukol sa pinopromote niya na yon. Tama? Tindi po nitong meme na to, mga kahombre ko. Sobrang, this guy is legendary pagdating sa memes, no? Meme world.
Putang ina nyo.
Halimbawa, sa naging post ito ukol sa isang gaming post na may status na bro is not safe. Bro is not safe from. Bro thinks he is safe from. Bro being hunted by the is it who is hunting you? Bro thinks he is safe. Oh my God. Bro, iba't ibang tao to ha, pero same content, parang pinag-usapan. Same comments, oh, parang pinag-usapan to. Tindi ng hatred na inabot ng batang ito, mga kahombre ko, lala.
Ngayon, sa mga gumagawa nito, you are evil people.
Para lang sa 30 minutes na post na gano'n. Isa pa rito ang post niya sa paglalaro ng Valorant, kung saan showcase ito ang server region ng Manila. Play the server instead. Manila server like many players. Just Manila may be. Nagkaroon din dito ng mga sari-saring memes ukol kay Razi commented sa kanya mga post. Oh my God. Yung apelido niya, mga kamera ko, grabe na to. Abing. Oh my God, man, what the F? Fuck! Sa sitwasyon na ito, hindi naman bothered si Razi Binks at sumasabay na lang siya sa nasabing insidente. Some dude just came up and gave me this. Bingo. Anyway, mga kahombre ko, ano ba ang take ko dito, no? This is just a funny and laugh trip, man. LOL content.
Putang ina mo!
Pero, inulit-ulit ko na nga ito, no? We are just waiting kung ano ba talaga ang gagawin ng mahal na gobernansa sa sitwasyon na ito. Sorry, man. It's just funny. It's still funny, man.
You will be accountable for that.
Grabe ito nangyari kay Razzie Binks na to. Shit, man.
You are pieces of scum and you need to be stopped.
Grabe ito. Ang lala. Anyway, hindi natanggap ng fanbase ni Razzie Binks na siya yung nag-post. Alam mo ibig sabihin ng Razzie?
Putang ina mo!
Ibig sabihin nun, ganun silang ka-disappointed sa'yo. Disappointed ang tao sa'yo kasi they were expecting something big from you. So you should be happy. And as long as hindi mo na yan ginagawa o hindi mo na yan ginawa at totoong nag-repent ka sa parte na yan ng buhay mo, then man, it's gonna be okay.
Repent!
Normal lang yan. People makes mistake. It's okay, man. As long as alam mo at ikaw nagpatawad na sa mga tao at di mo na ito ginagawa, man, it's okay. Diba? Pero syempre, ang problema, kapag inulit mo ulit, yari ka. Kaya, ewan ko, man. Ewan ko, Razzie Binks. Ano bang plano mong gawin? Huwag ka na mag-promote? O join us? Joke lang.
This guy should be more accountable sa mga sinasabi niya.
Anyway, bahala ka. It's your life, Razzie. Pero, yun. At least nakuha mo yung biggest Filipino meme sa buong social media. Just, last my reaction, sir. Wala. Good fucking vibes.
Mga putang ina nyo kayo.
buddy.
Na ito. Na ito. Na ito. Na ito.
Example, we will use REST template, we will use web client, we will use Spring Cloud provided OpenPaint library. Well, once we know how microservices communicate with each other, next we are going to implement service registry. Well, we are going to use employee management project as an example to create a microservices architecture. Well, you can take any example of any project. For example, you can take e-commerce application, or you can take any healthcare domain related application. So you can take any project as an example, but follow the same steps to create a microservice architecture using Spring Boot and Spring Cloud. Well, we are going to create 3 core backend microservices: employee service, department service, and organization service. And all these 3 microservices have their own databases. Well, we are going to use MySQL database as a database for these microservices. Okay, so whenever you create a microservice in your project, make sure that each microservice should have their own database. Alright, once we build the microservices, next we will see how these microservices communicate with each other. Well, we are going to use different ways to make a REST API call from one microservice to another microservice. For example, we will use a REST template, we will use web client, we will use Spring Cloud provided OpenPaint library. Well, once we know how microservices communicate with each other, next we are going to implement service registry and discovery pattern in our microservices project. Well, Spring Cloud provides Spring Cloud Netflix Eureka based service registry module that we can use to implement service registry and discovery pattern in our microservices project. Well, service registry and discovery is very essential pattern that we can use to avoid hard coding, hostname and ports. Next, we will implement config server to externalize the configurations of all these 3 microservices into a central place, that is Git repository. Well, Spring Cloud provides Spring Cloud config module that we can use to implement config server to externalize the configuration files of all these 3 microservices into a central place. We are going to use Git repository as a storage for config server. Well, once we know how to use config server to externalize the configuration files, next we are going to implement API gateway. Well, API gateway plays a very important role in a microservices architecture. Okay, so whenever a client want to make a call to different microservices, then client have to remember the host name and ports of all these microservices. So there should be a solution where a client can send a request to the central component. So that is where the API gateway comes into picture. So whenever a client sends a request to the backend microservices, then client have to send a request to the API gateway post, and then API gateway, based on the routing rules, it will route that request to appropriate microservice. Okay, so this is how the API gateway plays an important role in a microservices architecture. Well, Spring Cloud provides Spring Cloud Gateway module to implement API gateway pattern in a microservices architecture. Next, once we know how to implement API gateway in a microservices project, next we are going to implement a distributed tracing in a microservices architecture. Well, Spring Cloud provides Spring Cloud Sleuth module which we can use to implement a distributed tracing in our microservices project. Well, along with Spring Cloud Sleuth, we will also use Zipkin to visualize the tracing log information in a user interface. Well, Zipkin provides a user interface to track the trace information through web application. Okay, so once we know how to implement distributed tracing using Spring Cloud Sleuth, next we are going to create a simple React application which will make a REST API call to backend microservices. Well, we are going to implement circuit breaker pattern in an employee service because employee service is internally calling department service, and let's say due to some reason department service is down, then employee service won't get a response from the department service, isn't it? And then again employee service will send internal server error to the API gateway, and then API gateway will send that response back to the client. Alright, so in order to avoid this kind of issue, we can use circuit breaker pattern. So this circuit breaker pattern helps employee service to avoid a continuous calls to the department service whenever department service is down, and this circuit breaker pattern will help employee service to return some default response back to the API gateway, and the API gateway will send that default response to the client. Alright, so this is the simple microservices architecture that we are going to follow to create a microservices project using Spring Boot and Spring Cloud. Consider in our microservices project we have multiple microservices. For example, microservice 1, microservice 2, and then microservice 3, and so on. Okay, and each microservice have a host name and port. For example, let's say microservice 1 is running on port 8080, microservice 2 is running on port 8081, and microservice 3 is running on 8083. And in order to scale our microservices project, we can run multiple instances of each microservices, right? For example, let's say if we want to scale microservice 1, then we can start another instance of microservice 1. For example, let's say the instance is running on port 8084 and another instance will run on a port 8085. Okay, and each microservice exposes the REST APIs. Alright, next here we have a client. It consumes REST APIs from multiple microservices. For example, let's say client consumes the REST APIs from microservice 1, microservice 2 and microservice 3. Well, in order to consume the REST APIs from microservice 1, microservice 2, microservice 3, client have to know the URL of all the REST APIs. Well, in enterprise application, we may have hundreds and thousands of microservices, and it is not a good idea that client have to interact with all those microservices, isn't it? So basically client have to remember all the host and ports of all the microservices that it want to consume. So in order to solve this problem, we can use API gateway. Well, API gateway basically sit at the middle of client and backend microservices, and whenever client want to consume the REST APIs from multiple microservices, then client have to first send a request to the API gateway. We don't have to interact with directly to the multiple microservices. Okay, so this is awesome, right? So client don't have to remember host and ports of all the microservices that it want to consume. It just have to send a request to API gateway. That's it. API gateway take care of routing that request to appropriate microservice. Okay, so this is how the API gateway solves the problem. Okay, client don't have to tightly coupled with multiple microservices. Client just have to send a request to API gateway. API gateway based on the rules or the URL rules, it will forward that request to appropriate microservice. So API gateway we basically use to route the request. And second is we can also use API gateway for load balancing. For example, let's say we want to scale microservice 1, then we'll start multiple instances of microservice 1, and then API gateway will take care of routing the request to particular instance. Okay, in this way API gateway also capable to handle the load balancing. Next, security. Consider we are not using API gateway, then what will happen? Each and every microservice have to implement its own security, and client have to authenticate with each and every microservice, isn't it? So this is basically a tedious process. Alright, so client have to authenticate with each and every microservice it want to communicate. So this is a tedious process, isn't it? So API gateway basically address this problem. We just have to implement centralized security in an API gateway. Client just have to authenticate with API gateway. That's it. Client don't have to authenticate with each and every microservice it want to communicate. And API gateway will take care of authenticating the client request. And if there is an issue, then API gateway will send a response back to the client. Alright, so API gateway will address this security cross-cutting concern as well. Now let's take a look into the slides. API gateway provides unified interface for a set of microservices so that clients no need to know about all the details of microservices internals. It means that API gateway will hide all the microservice internals. Okay, so client only have to send a request to API gateway, and API gateway will take care of routing that request to appropriate microservice. Next, API gateway centralize cost-cutting concerns like security, monitoring, rate limiting, etc. Well, we can implement a centralized security in an API gateway. We don't have to implement a security in each and every microservices. Okay, and whenever client sends a request to API gateway for authentication, then API gateway will take care of authenticating the request, and if there are any issues, then API gateway will send a response back to the client. Okay, in this way we can implement centralized cost-cutting concern like security. Now the question is how to implement API gateway in our Spring Boot microservices project. Well, Spring Cloud provides Spring Cloud Gateway to create a API gateway. For example, if you look at the architecture over here, we can implement API gateway in our Spring Boot microservices project using Spring Cloud Gateway library. Well, if you go to browser and just search for Spring Cloud Gateway and go to the official documentation, you can go ahead and read all about Spring Cloud Gateway over here. Well, Spring Cloud Gateway is a part of Spring Cloud framework, and Spring Cloud Gateway provides a library for building API gateway on top of Spring Web Flux. Alright, if you want to know more about Spring Cloud Gateway, then you can go ahead and check out the official documentation. In microservices projects, service registry and discovery plays an important role because we most likely run multiple instances of services and we need a mechanism to call other services without hard coding their host names or port numbers. For example, in typical microservices project, we have a lot of microservices. Consider we have 3 microservices in our microservices project, and in order to scale our microservices project, typically we start multiple instances. For example, let's say I want to scale microservice 1, then what I will do, I will start multiple instances of microservice 1. For example, let's say instance 1, instance 2, and so on. And consider microservice 1 is running on port 8080 and microservice 2 is running on port 8081 and microservice 3 is running on port 8083. And whenever we start another instance of microservice 1, then this instance port should be unique. Let's say this instance is running on port 9091 and this instance 2 is running on port 9092. Next, let's say we want to scale microservice 2. Then what we'll do, we'll start multiple instances of microservice 2. For example, let's say microservice 2 instance 1 and then microservice 2 instance 2 and so on. Right. Next, let's say microservice 1 want to communicate with microservice 2. Then microservice 1 have to know the host name and port of microservice 2 as well as its instances. Okay. And again, let's say if microservice 1 want to communicate with microservice 4, then microservice 1 have to know the hostname and port of microservice 4. If you can notice here, microservice 1 have to know the hostname and port of each and every microservice that it want to communicate, isn't it? And let's say if we want to start another service of microservice 2, then we need to also configure that instance hostname and port in a microservice 1. Okay, so this is the pain basically, isn't it? As a developer, we need to configure a lot of stuff. Okay, and there should be a mechanism where we need to only configure the microservice 2 ID, so that microservice 1 can directly talk into microservice 2. Microservice 1 don't want to talk with the other instances. Okay, that is where the service registry comes into picture. If we use service registry, then microservice 1 don't have to bother about the hostname and port of all the microservices and instances that it want to communicate. So microservice 1 have to only know about the microservice 2 application name or the ID. That's it. Service registry will take care of configuring the appropriate request. In microservices project, service registry and discovery plays an important role because we most likely run a multiple instance of services and we need a mechanism to call other services without hard coding their host names and port numbers. So this is what the point we have discussed over here, right? So if we use service registry, then we don't have to bother about the host name and ports of the microservices and its services. All right, let's take a look into the second point. In addition to that, in cloud environments, service instances may come up and go down anytime. So we need some automatic service registration and discovery mechanism. Well, in typical microservices project, we may have a lot of microservices and its instances running, right? And we need to keep track of all the microservices and its instances at a single place. That is where the service registry and discovery comes into picture. So basically in our microservices project, we need to register all the microservices to service registry, and service registry will track all the microservices and its instances, and we can use service registry to see what are the microservices are up and what are the microservices are down. Okay, in this way we can use service registry and discovery to keep track of all the microservices and its instances in our microservices project. Now the question is how to create a service registry and discovery in our Spring Boot microservices project. Well, Spring Cloud provides Spring Cloud Netflix Eureka project to create a service registry and discovery. Well, let's first understand what is a problem and what problem Spring Cloud Config Server solves. Consider in our microservices project, we have multiple microservices. For example, let's say a microservice 1, and then microservice 2, and then microservice 3, and so on. Okay, and in order to scale our microservice project, we basically start multiple instances of each microservice. For example, let's say we want to scale microservice 1, then we will start the multiple instances of microservice 1. For example, let's say instance 1 and instance 2 and so on. Okay, and each microservice has a configuration files. It contains the microservice level configurations. For example, let's say microservice 1 has the configuration file, and similarly microservice 2 has a configuration file, microservice 3 has a configuration file. And consider we have a requirement to update the configuration file of microservice 1. Then what we need to do is we need to restart microservice 1 as well as its instances. Alright, so this is not a good idea. Each and every time whenever we update the configuration file, we need to restart the microservice as well as its instances. This is the problem Spring Cloud Config Server addresses. If we use Spring Cloud Config Server, then we no need to restart the microservice and its instances whenever we change its configuration file. Okay, so first problem, restart. Okay, so if we use Spring Cloud Config Server, then we no need to restart the microservice and its instances whenever we change the configuration file. So this is the problem the Spring Cloud Config Server solves. Next, we can use Spring Cloud Config Server to externalize the configuration files of each and every microservices. Right now, each and every microservice has a configuration file in its project itself, right? So we can use Spring Cloud Config Server to externalize all the configuration files of all the microservices in a central repository or a central place. For example, let's say Git repository. Alright, so if we place all the configuration files of all the microservices in a central repository, then we no need to go into each and every microservice to change that configuration file, right? So whenever there is a requirement to change a project specific configuration file, then we can simply change in a Git repository so that it will get reflected in that particular microservice. We don't need to dig into that microservice and change that configuration file. Alright, so this is the problem also Spring Cloud Config Server addresses. So these are the two major advantages of Spring Cloud Config Server. First one is whenever we change the configuration file of that microservice, then we no need to restart that microservice as well as its instances. Second advantage is like we can externalize all the configuration files of all the microservices in a central place, so that whenever we have a requirement to change a project specific file, then we can simply go ahead and change in that central place. We no need to go into that particular microservice and change the configuration file. We can simply change at a central place. Okay, so these are the main advantages that Spring Cloud Config Server provides. Alright, great. Well, let's first understand what's the problem and what problem the distributed